Okay, hi everyone. In this video, I'm going to demonstrate uh, the simplex method for this linear programming problem, the Soundex satellite radios problem. Okay, and this is one that we've done previously in class, and then also I made a video on how to do this or working out the details geometrically. Um, so if you haven't seen this example, make sure you watch the previous video, one of the previous videos. The link for this one will be in the description. Uh, but we're going to now do this using the simplex method, okay, that we talked about the chapter 4 materials, okay. So to get started, just to remind us what's going on, we have Soundex is making two models of satellite radios, Model A and Model B, and there's some constraints on these radios, okay? And they want to maximize their profit, okay? So they want to make as much money as possible, but due to restrictions on the company, they have some constraints, okay? So let's start by writing that down, okay? So they want to maximize so maximize profit. Okay, so profit P equals, okay, so I'm just going to copy this down, 12x plus 10y, subject to constraints, okay. Okay, and then the constraints are, so they're all right here, okay. So if you're not sure where these come from, make sure you watch the other video so you know where these come from, okay? The first step to these linear programming problems involving word problems, you have to set up these problems. You have to set up the objective function and your constraints, okay? Even before you do this, what we should really be doing is writing down our variables, defining our variables. So even before I did all this, I should have said that, well, x is the number of Model A radios, and then y is the number of Model B radios. Okay, so again, if you don't know where these come from, make sure you watch the previous video. Okay, so in particular, this x less than or equal to 80 is coming from this line here because of previous overproduction. Management decides to limit the production of Model A radios to no more than 80 per day. So no more than 80 means you're less than or equal to 80. Okay. Okay, so with that in mind, okay, we're going to go ahead and solve the problem using the simplex method, and then we'll check to see that we got the same answer, okay, when we did it geometrically, okay. So here we go. Okay, so I'm going to start by transferring this into the linear system, okay, by adding my slack variables, okay. So I'm going to add slack variables, and this is how it works, okay. For each of the constraints that are sort of non-trivial, okay, so this is what I would call the trivial constraints. These are the trivial constraints. And these ones here, when I say trivial, I just mean that they sort of are for free. You want to make non-negative amounts, okay, greater than or equal to 0 amounts of radios, okay? You can't make a negative number of radios, so that's why these are kind of trivial, okay? So for every non-trivial constraint, so this one, and this one, we're going to add a slack variable, okay? So since we have 3 of them, we're just going to add a U, a V, and a W, okay? So if there were more of them, so if there was 4 of these, you would add, you need another letter, okay? Okay, so, and then we need a slack variable for the profit function, the objective function. That one's in this book, they use big M, okay? So we need to add slack variables and transform to linear system. Okay, and so when you transform to a linear system, the way you do this, well, since we're adding these slack variables to each of these constraints here, this variable takes up the slack that would be in the inequality here. Okay, so let's put that into there. Okay, so you have 15x plus 10y. Okay, so now you're going to add one slack variable u, and then now this equals 1500. Okay. Okay, and then similarly for the next constraint, 10x plus 12y, okay, now this constraint gets the second slack variable, v, equals 1320, okay, and then this third one here, you got x, okay, plus a w, okay, so this is the third slack variable, will equal 80, okay, and so far, the idea of this is that these constraints here are all inequalities, okay? So if there's a solution to this problem here, if you can figure out an x and a y that gives you the biggest profit subject to these constraints aren't necessarily met, okay? So the difference between the two will be given by the slack variable, okay? So for example, just really quickly, in the context of the problem here, the first constraint here, this 15x plus 10y, comes from, well, assembly line 1 has 1,500 minutes available for usage during the day, okay? And it takes 15 minutes for a Model A radio and then 10 minutes for a Model B radio. So if you make X radios, X Model A radios and Y Model B radios, then this is how much time it takes on assembly line 1, and this is how much time you have at most, okay? You might not use up all that time, okay? You might not use the 1,500, so the difference of the maximum amount of time and then the time that's spent is given by u. That's what this is. It's taking up that slack variable, okay? So that's what that means there, okay? Now, to finish off the problem, what we actually have to do is incorporate the objective function, okay, with this m. And the idea is, it's a little bit funny, but what's really happening here is, well, m is really p. It's just the biggest p possible, okay? So m is really 12x plus 10y, but it's the biggest p possible. So let me write that down. Okay, this is the biggest p. The biggest profit, okay? And that's what we're trying to find. We're trying to find m, essentially, okay? In this problem, remember, we're trying to decide how many radios, okay, we need to maximize the profit, okay? So what happens here, how do you incorporate this into here? Well, we need to really, what we're doing here and what we've been doing is writing everything into this standard form. And standard form is where you have variables, okay, on one side, okay, variables on one side, and then equal or less than a number, okay? Okay, so that's what's going on here, okay? So we really want our sort of, even before we started here, we want everything to look like this, variables equals number. So what I did in class when we did this, we would subtract this to the other side and then make it equal to 0. So that's what I'm going to do. So subtract 12x, subtract 10y. Okay, so that will give us, okay, minus 12x minus 10y, okay, plus the m, okay, equals 0, okay, and that's what goes here, okay. Okay, so this is our linear system, okay. We've transformed this system of linear inequalities to a system of linear equations now, okay. Okay, so take a second, make sure you're okay with this transformation here. If you need to, pause the video and just make sure you're okay. By the way, the resource that I'm sort of working out of or sort of thinking about is on page 155. It's this green box here, the Simplex Method for Problems in Standard Form, okay? And remember, standard form, so this is in 4.2, page 155. Standard form is where you have, let me back up for a second here, is where you have the expression is less than or equal to a non-negative constant, okay? So technically speaking, the method that we're doing right here only works for things where you have less than or equals to. Okay, so I should really put a less than or equal to. This is the standard form. Okay, it's just that when we have the objective function, you want to also make that standard form, so that would make that equal to 0. Okay. Okay, so pause, make sure you're okay. If this looks a little bit funny, I will in another video explain why we're doing it like this and why we're not subtracting by m. Okay, so why did I subtract all this to the other side? It's the way this method particularly works. Okay, so in the follow-up video, I will explain that a little bit more in depth. But right now, I just want to get through the problem here. Okay, so if we're good, we're going to now write down the simplex tableau, which is basically the augmented matrix associated to the system. Okay, so that is given by, okay, well, you're going to have a matrix here. Okay, and well, we have 6 variables here. You got x and y. These are the number of model A and model B radios, but then you got U, V, W, and big M. Okay, so you got 6 variables here. Okay, so this is a system in which you have 6 variables. Okay, I'm writing them down right now. Okay, and then 4 equations. Okay, 4 equations. So you got, so to transfer the system over, remember, it's like you write down all the numbers next to the variables, and then the numbers that don't have a variable, you write them on the right-hand side here. Okay, so you got 15, you got 10, you got 1, 0, 0, 0, because you have no VWM here. Okay, so that's 1500. Okay, 10, 12, okay. You have no U, okay, so that's a 0 here, and then you have a 1V here, okay, so 1V, 0 W's, 0 M's, and 1320, okay, okay. Here you have 1 for X, 0 Y, 0 U, 0 V, and then 1 W, okay, no M, and then 80, okay, and then minus 12, minus 10, okay, or negative 10, and then zeros for the UVW, and then M has a 1 here, okay, so that will be, and then 0 right here, okay. This is the simplex tableau, okay, and the way kind of convention is to draw a line that separates the constraints. These are the constraints here, and then this is the objective function information. So we just draw a line here to separate the two, and these are each row corresponds to a constraint. Okay, so and this corresponds to that we've added a U to the first constraint. So the first constraint was this, and we added a U to it. Okay, we added U to it. So U here. The second one, we've added a V to it. Okay, and then the third one, we added a W. Okay, that's going on here. Okay, so take a second, make sure this to here is okay. This is the simplex tableau, okay? So simplex tableau. Tableau, okay. Okay, so if we're okay, we're going to begin the process now for finding the solution, okay? So we're finding this solution here. And as we saw in class, it's a little bit sort of all over the place. So I'm going to, again, in this video, I'm going to go through the method and go all the way to the end. In the follow-up video, I will explain why we do these steps, okay? So here we go. So the method that we're going to do is, well, the idea is what we want to do, the ultimate goal is we want to get rid of these negatives in the bottom row, okay? So that's kind of the goal of this method here, okay? So the goal, okay, eliminate okay? Negative numbers, okay? Okay, so 0 is okay. Positive is definitely good, but you no negatives here, okay? Okay. Okay, so that's the ultimate goal, okay? So what we're going to do is do that process, which I'll describe in a second, where we get another matrix, and then if we see another negative, if we see any negatives, then we have to do that process again, okay? Until there's no more negatives down here, okay? What's that process? Well, here we go. We start by looking at the bottom row, and you look at the most negative number, okay? So the most negative here is negative 12, okay? So we're going to consider this column here, okay, because this is the most negative, okay? So this is one reason why that in setting up the this system here is there's one reason why that we had to move this over like this so that we're looking at the most negative, okay? So most negative, and then now we have to do we have to pick an element up here, okay? And how do we pick that element? We consider the ratios of the augmented column on the right-hand side divided by these, okay? So ratios of this with this, okay? And the constraint is that these have to be positive, okay? So we're just going to look at, for example, 1500 divided by 15. 1320, okay, divided by 10, okay, and then 80 divided by 1, okay. And what we're doing is looking for the smallest one. So 80 divided by 1 is 80, okay, so that one's not too bad. 1320 divided by 10 is well, you just kind of cancel out the 0, so it's 132. And then 1500 divided by 15 is just 100, okay. Okay. So, and we're looking at the smallest. So since this is the smallest here, this is the smallest, the method says, okay, we're going to pivot about here, okay? So this is the element that we're going to pivot about, okay? So what does pivot mean? It means that you're going to do Gaussian elimination and make everything else in this column a 0. So I'm going to make this a 0, make this a 0, and make this a 0. And then if this is not 1, divide so that it is 1. Okay, so since it's 1, we don't have to do anything here. But now we're going to use Gaussian elimination to get rid of the 10, the 15, and the negative 12. So here we go. Okay, so I'm going to start by rewriting this matrix here. Okay, and this row is fine. The third row is fine because there's a 1 here, and that's the one that's staying put. So I'm going to rewrite the third row here. Okay, and just to be safe, I'm going to write down these variables x, y, u, v, w, m. Okay, and I'm not going to rewrite these yet because there's going to be some switcheroos that happen. So we're going to just leave this alone here. But we're going to start doing Gaussian elimination. Now, this is nice here because, well, there's a 1 here. So if you want to make, for example, this 0, you just multiply this by like -10, and then you add, and then this row to this row, and then that will give you 0 here. Okay, so for example, for this second row here, maybe I'll multiply by -10 here, so maybe I'll have like -10. This will just be 0 if you multiply by anything, okay, by -10 in particular. So this one will be 0, 0, okay. This one will be a -10. This will be a 0. And then this one will be -10 times 80, that's -800. Okay, so now we're going to add, so 10 minus 10 is 0, 12 and 0 is 12, 0, 0 is 0, 1 and 0 is 0, is 1, okay, 0 and -10 is -10, 0, 0, 0, and then you got 1320 minus 800, okay, so if you're not awake right now, that's okay, we can use our calculator here, 520, okay. Okay, good. Okay, so now we're going to do this really quickly for all the other ones. Okay, so I'm going to do this a little bit straightforward. Check the Gaussian elimination if you need to. So I want to make this 0 here, so I'm going to multiply this by -15. So -15. Okay, so I can't really see that. negative 15 times 0 is 0. So you're going to see that because we have a lot of zeros in here, it's not going to be too bad in the sense that only some of the operations require some thinking. So here, negative 15 times 80 is, I don't know what that is. Okay, it's negative 1200. Okay, and then I'm now adding this row with the negative 15 times the third row. So you're going to have 0 here. Okay, and replacing the first row with this addition, you got 10 here, got 1, so oops, 10, 0 and 0 is 0, 0 and negative 15 is negative 15, and 0, 0, 0, and then 1500 and minus a 1200 is a 300. Okay, and then finally we just have to do this last row here, and we just have to multiply by positive 12. Okay, so positive 12. So I'm just going to ignore these because these are just all zeros here. Positive 12, this is still 0, and then 12 times 80. 12 times 80, well, 12 times 8 is, what's 12 times 8 is 96, so this will be 960. Okay, so now I'm going to have 0, negative 10, 0, 0, and then 12, so 12 and 0 is 12, okay. So this is a 0 here, not a 6, okay. 1, okay, and then, well, what was here? 960, so 960 and 0 is 960, okay. Okay, so this is what our new simplex tableau looks like, okay. And then one thing before I forget that happens is that in doing this simplex tableau, oh, so by the way, M is down here. This is the M here, okay? In doing this simplex tableau, by pivoting about here, remember pivoting means that you do Gaussian elimination and you make this, all the other entries in this pivot column 0, okay? So that's what we did here using Gaussian elimination, okay? And in doing this, the method says that we've kind of swapped out this slack variable w for x, okay? So these will stay the same here, but now this w now becomes an x, okay? And then all the slack variables stay the same, u, v, and m, okay? It seems a little bit strange this entire method might seem strange at first. Again, in the next video, I'll try to explain why we are doing these steps, okay? Why we're choosing the most negative, the smallest ratio when you do this divided by the positive stuff here, and choose the smallest one, and then swapping the w with the x here, okay? We'll try to explain all that in the next video. But now we're going to keep going. Again, the goal is to eliminate negative numbers in the bottom row. Oh, the bottom row here, we have a negative number, okay? This is the only negative number, but we still need to get rid of it, okay? So by eliminating, by doing this method. So this is the most negative, it's the only negative, so it's the most negative, okay? And we're going to, well, we have to do that game where we look at this stuff here in the above the line divided by this stuff here, okay? So, and we have to look at the positive elements here. So we got 300 divided by 10, okay? So that's 300 divided by 10 is just 30, okay? We're going to have 520 divided by 12, which I don't know what that is. Okay, so 520 divided by 12. Okay, that's 43 point something. Okay, great. Yeah, okay, great. Okay, and then we have 80 divided by 0. Okay, so this we're not going to consider because, well, 1, 8 you can't divide by 0, so that just doesn't already make sense. But then 2, this wasn't positive to begin with, so we're not going to consider this. So we don't consider this ratio because it's not positive, okay? Because not positive, 0 is not positive, okay? Because this not positive, okay? So if it was negative, like we saw in class, we actually don't consider it, okay? It has to be with the positive ratios. Again, why do we do this? It'll be explained in the next video, okay? But now that we've done this, okay, we can, we're ready to go. We look at the smallest one. So the smallest one here is this one here. This is the smallest, okay? And well, that means we're going to pivot about 10, okay? So that means this row is good, except we just have to make this a 1 by dividing by 10, so that won't be too bad. But then all of these have to become 0, okay? So this row is good here, it's already 0. We're already like halfway there, okay? But we have to make these 0, okay? So we're going to get started there, okay? Okay, so I'm going to draw another matrix here, okay? Okay. Okay. And so since the third row is okay, I'm actually going to keep that because that's okay here. Okay. So the third row is fine because we want this to be 0. It's already 0. Okay. So we can keep that okay. Now, a couple things here that will help us. And the more you do Gaussian elimination, you figure out all these like tricks. If you remember from chapter 2, you figure out these tricks so that you find the quickest way to do it, okay? So I know I just said we want to divide this by 10, okay? But before I divide by 10, I noticed that this is a negative 10 here, okay? So I want to make this 0. So if I just add this together, add this row and this row together, then it'll be 0. And I will have gotten a step out of the way. So before I divide the top row by 10, let me add it this row and this row, row 1 and row 4, so that I get 0 here. Okay, so 10, negative 10 is 0. Of course, 0 and 0 is 0. Okay. Okay. 1 and 0 is 1. 0 and 0 is 0. Okay. Negative 15 and 12 is negative 3. Okay. Okay. And then 0, 1 is 1, okay? And then 300 and 960, okay, so 300 plus 960, that's going to be 1,260, okay? Okay, so good. So by doing this step, we've taken sort of care of this row here and made this part 0, and we can now just have to focus on this row here, and then also just need to divide by 10. Okay, so let's quickly do that. If we divide by 10 here, so this one we just have to divide by 10 because we want to make it a 1. So dividing by 10, so 10 divided by 10 is 1. 1 divided by 10 is 1/10. So if you want to stick it with fractions, you can. You could also do decimals. Okay, so I'm going to stick with fractions just because I like them a little bit better than decimals. 0 divided by 10 is 0. 15 divided by 10, so that would be a negative 15th over 10. I know this simplifies, but whatever, let's just leave it as is. And then 0 is 0, okay? 300 divided by 10 is 30, as we saw here, okay? So now we just have to figure out this row here, and then we will be done, okay? So we have to figure out this row. Now to figure out this row, well, since we divided this one by 10, we can multiply this by negative 12, and then add them together, okay? So now to make that all clear, okay, multiply this by negative 12 and add it to this row, I'm just going to, for the time being, rewrite the second row here, okay, and then make a new simplex tableau, make a new matrix here so it's a little bit easier to see, okay? So here's the plan. Multiply this one by negative 12, add it to this row here. So let me rewrite this row here really quickly. And I'm going to rewrite it in just a different color here. Maybe I'll do purple. Okay, so 0, 12, 0, 1, negative 10, 0, 5, 20. And I'm multiplying. So this, again, we haven't changed this row yet. Okay, but now we're going to multiply this by negative 12. So negative 12 here. Of course, this is 0 here. Negative 12 over 10. Okay, whatever that is. 0 times 12 is, okay, 0. Okay. So we have to be a little bit careful here. Negative times a negative will be positive. So this will be whatever 12 times 15 divided by 10 is. Okay, so 12 times 15 divided by 10. So I'm just going to, for the time being, just write 12 times 15 divided by 10. Again, we're multiplying by negative 12. This is just 0. And then 30 times negative 12 is just well, what is it? It's 12 times 3 is 36, so that's going to be a negative 360. Okay, Great. So hopefully you're hanging in there, okay? But now we're just going to add the first row and the second row together. The first row multiplied by negative 12 together here. Okay, so everything in black can be recopied down, so I'm going to quickly do that. Okay, so the second row I'm going to leave blank because that's the thing that we are working on right now. Whoops, something just fell back there. Okay. Okay, and we're going to carefully add now. So 0 and 0 is 0. 12 and negative 12 is 0. Okay, so these two aren't that bad. You got a negative 12 tenths. Okay, here. Now negative 12 tenths is, okay, well, let's maybe just simplify that really quickly. Negative 12 tenths, if we take out a 2 from the upstairs and the downstairs, you'll just have negative 6 fifths, okay? So negative 6 fifths. And that goes here. Okay, 0 and 1 is, okay, 0 and 1 is 1. Okay, and then now we got to think a little bit here. Okay, so 12 times 15 divided by 10. Okay, so 12 times 15 divided by 10. Well, 12 over 10 is negative 6 fifths. Okay, but then you have a 15 on top of that. Okay, so that cancels out and gives you a 3. Okay, so you'll actually have a positive 18. So let me write down what I just said here. 12 times 15 divided by 10. Some of you might have figured this out. This is just 18. Okay. Okay. So that's 18. So 18 minus 10 is, well, 8. Okay. Okay, so 0, 0, 0, and then 520 minus 360 is, okay, well, maybe I need my calculator here. 520, oh, turn it on. 520 minus 360 is 160. Okay, so this is our new simplex tableau that we got here. Let me relabel the letters here. And as I mentioned in the previous, okay, when we, the previous simplex tableau, we got some switcheroo here. So originally it was this one here, and then we went up here and then went down here to finish it and get everything under the 10 zeros and make the 10 a 1. But now the slack variable gets swapped out. What does it get swapped out with? It gets swapped out now with y. So u becomes y, okay? V stays the same, X is still the same, and M is still there, okay? Okay, so take a second, make sure you're okay, because we're gonna have to do this one more time, because again, the goal is to eliminate negative numbers in the bottom row. We got one negative here, so we gotta keep going, okay? So take a second, pause if you need to, make sure the Gaussian elimination is okay, and then if you are okay, we're going to keep going. So here we go. So we got to do the same game as before. Okay, so this is the only negative, so it's the most negative. Okay, so this is the only one that we can look at here. Okay, so as before, if there were more negatives, then you have to choose the most negative. But because there's only one negative, this is the only one you choose. And if there are no negatives, then we would be done. Okay, but we're not done. So now we have to play the same game. Okay, you have to look at ratios of this stuff divided by this stuff here, okay, where this stuff has to be positive. So we're not even going to look at this divided by this because it's not positive. So we just have to focus on these two here. Okay, so this one here is a 160 divided by 8. This one is an 80 divided by 1. Okay, so now we just have to figure out which one's the smallest here. So 80 divided by 1, that's just 80, of course. 160 divided by 8, well, that's just 16 divided by 8, and then put a 0, so that's just 20, okay? So this one's clearly the smallest, okay? 20 is the smallest here, okay? So that means we have to pivot about here, okay? So now we're going to have to make this a 1, and then everything else a 0 here, okay? And this is where we're going to have to be patient because there's going to be fractions, and might be a little bit tired right now, but we can do this, okay? So we can do this. Now, again, we are not considering this one. We don't consider 30 divided by whatever this fraction is because of the negative sign. We don't consider this, okay, because negative 15 tenths is negative, okay, so because of this. Okay, so it has to be with the positive numbers here, okay? So here we go. We need to make this a 1 by dividing by 8, and then we need to make it 0, 0, and 0. I think a simplest way to do this, because of the different numbers here, is to divide the second row by 8 and then deal with each row one at a time. So let's try that, okay? Now, if you're watching this and you go like, Jackson, there's something else you can do that's a little bit faster, feel free to put it in the comments, but this is how I will do that here. So I'm going to, because this row is, the second row is the pivot, or I'm sorry, the second row has the pivot element, the 8 that we're keeping, I'm going to write that down first, okay? So we're dividing everything by 8, so that will be a 0, 0, okay? So I'm doing negative 6/5 divided by 8. Negative 6/5 divided by 8. So, okay, so negative 6/5 divided by 8. Okay, so if we do some fraction arithmetic here, this is just, okay, well, this isn't just negative 6 divided by this moves in down here, so 40 here, okay? Okay, so now we're going to have, if we take a 2 out from the top and the bottom, we'll be left with negative 3/20. Okay, again, if you wanted to keep decimals, that's fine here. I just like fractions a little bit better. 1 divided by 8 is 1/8. 8 divided by 8 is 1, and then this is just 0, and then 160 divided by 8 is 20, okay? Okay. Okay, so sorry, this is supposed to be straight here, okay? That's the second row, but now we have to deal with everything else, okay? We have to deal with everything else. So to deal with everything else, I'm going to start writing by, because this is I made this a 1, I'm going to start by rewriting all of the other rows, okay? So, and I'll use different colors so we can keep track here. So I'll start with this one here. This is a 0, a 1, a 1/10, a 0, a negative. So negative 15 tenths, if you simplify this, if you take out a 5, that's just negative 3/2. Okay, so that's not too bad to keep around. 0, and then this is just regular 30. Okay, so no simplification there. This one here, let me use another color here. This one here, I'm just rewriting down these rows here. So 0, 0, 0, 1, okay, there we go, 80, okay. And then the last row here, which I'll use blue here, so 0, 0, 1, 0, negative 3, 1, 1, 2, 6, 0, okay. So again, all I've just done here is divide the second row by 8, so now this is a 1, and now I'm just rewriting all of the rows down in preparation of pivoting by doing Gaussian elimination and making these all 0 here, okay? So this green row is not going to be too bad because we can just do green minus the black, and then that will make this part 0 here. So let's quickly do that one. That one won't be too bad. Okay, but the other ones we're going to have to think a little bit because of the fractions and stuff. So let's see. The second row is fine. The second row is perfectly fine here. Let's see. Second row is fine. Okay, so if I do green minus black, that would just be 1. Okay, so let me draw the line here. 1, 0 minus 0, 0. And then be careful here, 0 minus a negative, so minus a negative is plus now, so that's just plus 3/20. Okay, 0 minus negative 1/8 is negative 1/8, okay. Okay, and then now 1 minus 1 is 0, and then 0 minus 0 is 0, and then 80 minus 20 is 60. Whoops, okay, there we go. 80 minus 20 is 60. Okay, so now that we've gotten rid of the green row, we're going to very carefully do some Gaussian elimination to get rid of this 0. Where are we pivoting? We're pivoting about 8, this W column, so maybe let me just quickly write down U, V, W, M. Okay, so we're pivoting about this one here. I want to get rid of the -3 here. So what you can do is multiply this 1 by a 3. Okay, and we have to do it across. So this will be now, okay, so bear with me, 3/8 here. Okay, this will be a -9/20. These are 0, so I don't have to worry about them so much. Okay, this is 0, and then I'm multiplying by 3. This is a 60. Okay, here we go. So 0, 0 here, so 0, 0, okay, -9/20 and 1, okay, so, okay, so we have to think a little bit, so this will be 20/20 minus 9/20, which is 11/20, okay, so you can also use your calculator too if you don't want to think, okay, too much, so 1 minus 9/20, okay, so I know that gives you a decimal, but if you click on math, and then frac, and then equals, if you have a TI calculator, that gives you 11/20. Okay, so, okay, 0 and 3/8 is 3/8. This is 0 because we want it to be 0, and then 1 and 0 is 1, okay? And then here, 1260 plus 60, okay, so 1260 plus 60, maybe we'll pull out the calculator here, plus 60 is 1320, okay? Okay, so I'm excited right now because I know we're not done yet, but I'm very excited because this row is all positives, okay? So this bottom row is all positives. That means we don't have to do anything after this, okay? That means we'll be done as soon as we finish this row. Okay, so let's get this row really quick. Let's get the answer, and then we can celebrate and be done. Okay, so to get the last row here, well, we need to make we need to make this -3/2 is 0. So we're trying to pivot here. We need to make this a 0 here. So the option that we have that we can do is just multiply this row by a +3/2 and then add it to the pink row, okay? So I'm going to very carefully, because it's easy to make mistakes here, just multiply this row by 3/2, okay? So 3/2. So this will be 0, so I don't have to worry about it. 0 here. If I multiply this by 3/2, well, I'm multiplying by 3/2, so I've already multiplied by 3, so really I just have to divide by 2 in each of these numbers here to get 3/2, okay? So I multiply by 3, divide by 2 now. So this will now be a, well, -9/40, okay? Because if you just divide by 2 here, this will be a 3/16, okay? Okay, and then this will be a 3/2, okay? Okay, and then this will be, well, again, we just need to multiply by 3/2. We've already multiplied by 3, so I just have to divide this by 2. So that would just be 60 divided by 2 is 30, okay? So again, just double check these numbers where they came from. I'm just multiplying the black row here by 3/2, but that's the same thing as multiplying the blue row by 1/2, okay? So if we're okay now we just have to carefully do some subtractions. Okay, so again, we got 0 here, 0 and 1 here, okay? So now you're going to have 1/10 and -9/40. Okay, so you're just going to have to do some fractions here. I'm going to come back to that because that will take a second here. This one I don't have to think too much. I have 0 and 3/16, so that's just 3/16. Okay, so I don't have to think too much there. This one here is 0 because I want it to be 0, and then this is 0 as well. And then here we're going to have 30 and 30, which is 60, okay? So the only one that we actually have to think about is right here, okay? And to think about that, well, that's just 1/10 minus 9/40. I'm not sure what that is, so 1/10 minus 9/40. Okay, so really quickly, well, we need a common denominator because that's how fractions work. Okay, so this will be a 4 minus a 9, which is -5, all over 40, which, you know, if you wanted to simplify, but at this point, it actually won't matter too much. This will just be a -1/8. Okay, so great. Okay, so that goes here. And we are basically done. Now, before we go home and celebrate, let's just remind ourselves, because we pivoted here, we need to do some switcheroos here. The v gets replaced with the w. So this slack variable gets replaced with w, okay? So v becomes w, and then x is there, and then m is there, okay? Okay, so we're basically done now, because we can stop now because there are no more negatives here. So we can stop, okay? Since all of these, since bottom row has no negatives, okay, so 0 is fine. Positives are definitely fine. Okay, but we're done here. We don't have to keep going. And basically, what the answer is, well, okay, so what we're going to do is x is now 60, w is 20, and y is 60, and then the maximum profit, that big M, is 1320. Okay, that's what the simplex method says. Okay, so it says that, okay, x is 60. Okay, so let me maybe write that down somewhere. Okay, y is 60, w is 20. Okay, so I'm kind of, it looks like I'm just circling random stuff here. Okay, so maybe I'll draw some arrows here so it's a little bit clearer of what I'm doing here. Okay, and then the maximum profit is this here. Okay, this is the maximum profit. Okay, so that's the answer basically. Okay, so x equals 60, y equals 60, and w equals 20. W is not that important to us. The x and the y are important to us because that was our original question. We want to find how many model A radios and model B radios, x and y, to maximize profit, and this is the maximized profit. Okay, so to make sure, and then to make sure that this makes sense before I stop, is that let's just take a quick look here. Okay, when we did this geometrically using the feasible set, okay, and use the fundamental theorem of linear programming, and then you check, we saw that this was the maximum, 60, 60, 13, 20. 60, 60, 13, 20. Okay, so we got the answer here. Okay, we got the answer. Now, one more small thing here is that what's going on here actually is that we have a particular solution, and it turns out the u and the v are 0 here. Okay. Okay. So in the next video, I will talk about where this all comes from and what's going on here and why this is 0 here. But for the time being, I'll just say that, well, going back to the original setup here of the simplex tableau, so I gotta get a little bit organized here. Oh, it's fell on the ground here. What this is saying here is that in this system here, well, x is going to be 60, y is going to be 60, and then w is going to have some slack here. It's going to be 20, okay? But then u and v won't have any slack, okay? U and v won't have any slack, so this will be optimized to the entire amount of 1500 and 1320. Okay, and then this will be our maximum profit here. Okay, so that's it for this video here. Again, look out for the next video where I will explain what's going on. Let me know if there's any questions in the comments below. And again, you do need to watch the previous video in order to understand what's going on here. So make sure at the very least you watch the first video where this happens geometrically so that this simplex method makes sense. Okay, thank you.